Hey guys, and in this video I'll be showing you how to solve your 4x4 Rubik's Cube using the reduction method, which is one step up from the beginner method. So basically, the beginning of this tutorial with the centerpieces is basically the exact same as the beginner method, so I will not go into the centers at all. If you know how to solve a 4x4 Rubik's Cube, then you should already know how to solve the centers, and therefore I will not need to go in them. If you do not know how to solve the 4x4, then I will leave a link in the description to a video that I made previously on how to solve this using the beginner method. So let's go ahead and get started. So to start off with the edges, we have this white and red edge, and this white and red edge. The main difference in reduction is the edges. That speeds you up a lot, actually. You'll be surprised. So what we're going to do is we're just going to do the same thing we would in the beginner method solve. We're just going to bring this edge down so it is diagonally across from the other edge piece. And then we're going to go ahead and slice it over like that. And we're just going to put it in the top layer like we normally would. However, we are not going to slice back. We're going to leave these center pieces unsolved. So that way we can save moves. Now on the beginner method, basically how you would do it is you just slice this white and blue over with this white and blue, put it in the top layer, and then move those centers back. However, that's a waste of moves. So because already we have this edge paired right here. So basically what we're going to be doing is we're just going to do that for all of the edges, at least until the last 4, which we'll get to that in a minute. So we have this white and blue edge, and this white and blue edge. Now we could do the algorithm that you learned in the beginner method, which is small d, r, f prime, u, r prime, f, small d prime, and that would pair those edges. Or another option you could do is bring one of these edges up into the top layer, move it out of the way, and then bring that piece down. And then from here you could do 2 more options. You could either rotate the cube, move it out of the way, bring this side up, move this edge in, and then bring it back down. And therefore they will then be diagonally across from each other. Or something else you could do is with the same edge, you could bring the front side counterclockwise once, bring this edge over, do a U2, and then do an F. As you can see, they are diagonally across from each other again. So we can go ahead and slice over like that. And once again, just go ahead and move it into the top layer, move it out of the way, bring an unsolved edge down. I mean, that's basically what we're going to be doing for almost all of these edges. Let's go over now with the white and orange edge. White and orange. As you can see, if we just move it out of the way and bring it down, they will be across from each other, which we do not want that. So what we're going to do instead is we're going to do F, U prime, F prime. And that will put that edge in the correct position. As you can see, when we slice over, they will be matching. So we can go ahead, move it into the top layer, bring an unsolved edge down in its place, and do not slice back over. Another good example here is green, white, and green, these edge pieces. Since we already have one white and green edge piece on these 2 layers that we are pairing with, we have this one piece on the top layer. So what we're going to do is we're going to move the left side up, so L prime, U, L. But you can see that inserted that edge piece in the correct position. So all we have to do now is just go ahead and move it over, move it up into the top layer, bring an unsolved edge back down. Now we have all of our white edges paired. So now it's time to move on to the red and yellow edges. since they are across from each other, which we do not want, we're going to go ahead and move it up into the top layer. Move it out of the way, and then bring this unsolved edge back down. So now we're going to go ahead and do this simple move set when we move it back over. We want to make sure that this edge piece is still on the same side, so if you moved it down, it would be in that old position. F prime, U, F. So as you can see now, we have these two edge pieces are directly across from each other, which is what we want. So now we can go ahead and move them over and bring it into the top layer. Bring an unsolved edge over and down, and that is that edge paired. So next here we have yellow and blue, yellow and blue. This is another really easy case. We can just go ahead and do L prime, U, L. So you can see that put it in the right position. So we can go ahead now and slice it over, move it into the top layer, get an unsolved edge in that position, and then move it back. So next we have blue and red, and then that same edge up here. So once again, we're going to want to move it so that it comes in on the side opposite of this edge. So if we moved it on this side, which is where we want it, to know that that's correct, we just have to move it down, and we can see that they are opposites. So we're going to go ahead and do this algorithm. F prime, U, F. And that correctly inserts it onto this layer. So you can go ahead and slice it over, move it into the top layer, bring an unsolved edge over, and then bring it back. Now another reason why we do not slice back like that is because we might have another edge that's paired already. So we can go ahead and just move that into the top layer, bring an unsolved edge over, and back down. Okay, so we have now completely solved 8 edges using the reduction method. Now we have the last 4, which is very similar to the beginner method. And you can see here, all the edges on the top 2 layers are solved. So on this layer, they're all solved, and on this layer, all the edges are solved. It's just on these 2 layers that the edges are not solved at all. And that's the same case we have here. If we go ahead and solve our centers now, we can see that we have only this time 2 edges that happen to be not solved. These edges could be swapped as well and make it 4 edges unsolved. So we're just going to do a simple algorithm that you probably learned in the beginner method, but I'll just go ahead and do it again. The algorithm is 2 down layers, F prime, U, R prime, F, 2 down layers prime. And that moved those 2 edges around. So that is basically the reduction method. Now I'll go ahead and go over all of the separate cases that you might have, so that way you know how to run into each one properly. Alright, so the first case here is very basic. We have this orange and blue edge piece right here, and the other one is right up here. So to get it down so that it's diagonally across, without messing up our centers, because you can see if we just moved it down, these centers would become messed up. So we're just going to move it out of the way, right side up, move it back over, and then bring it down. So as you can see, now it will be diagonally across. And we can just go ahead and slice it over, move it into the top layer here, bring an unsolved edge down, and then we have solved that case. Another case we have here is the white and red edge piece, and the other one is right over here. We want to get both of these down on this bottom layer in as few moves as possible. So what you should do is bring this edge over first. So bring the left side up, so L prime, U, L. and that brings this edge directly above it. So now we're going to go ahead and rotate our cube, L prime, U2, L. And that brings these two pieces diagonally across. So if we slice over, they're matching. Bring it up on the top layer. Put an unsolved edge in its place. Another case here is we have one white and green edge piece right there. Another one on the opposite side of the cube, but they're on the same layer. So for this case, what you need to do is move this edge into the top layer, place with an unsolved edge. Rotate your cube once, move it over, and then do F prime, U, F. And that'll put that piece in the correct position. So we go ahead and slice it over, move it into the top layer, bring an unsolved edge in its place, and move that back down. For this case here, it's almost the same as the previous case, but not quite. We have an orange and green edge piece right there, and we have another one on the opposite side, but they are not on the same layer. As you can see, if we just go ahead and move this piece over to match, they will match. So that case is very basic. So we just go ahead and move it into the top layer, and then bring an unsolved edge down. So for this next case right here, it is pretty basic as well. You don't get it too often, but you might sometimes. And that is when you have two edges that both have the same pieces on them, but they are across from each other, not diagonal. So what you can do is, for this case, basically just do the DD prime, or DD algorithm, R, F prime, UR prime, F, DD prime. And that will pair both of those edges. This next case here is also very basic. It's almost the exact same as the previous case. However, this time we can slice this piece over, and it will be matching with the opposite piece. So now all you have to do is just bring it in the top layer, move an unsolved edge down, and then we can bring this piece over by doing a U2, a small U2, and as you can see now it's matching. Move it into the top layer, and bring an unsolved edge down. So this is the first solve, and it is of the beginner method, and it's a lot slower, as you can probably already tell. And the way to notice this is that I get finished with the edges at around 1 minute and 14 seconds, and the final solve time is 1:48.28. This second solve here is of the reduction method, and the way you can tell that this is faster is that I get done with the edges at 50 seconds and the whole solve at 1 minute and 10 seconds, 0.18. I hope you guys found this video helpful, and if you did, then make sure to hit that like button down below, and please subscribe to Cubing Outlet. TS and I would really appreciate it.